Hi folks, in this video we're going to look at sequences and series. So these are things that you need to know. You need to be able to generate a sequence using either the nth term or a recurrence relationship. You need to be able to find the nth term of a series, which is called un. You need to find the sum to n terms of an arithmetic series, which is called Sn, and then solve problems using un and Sn. And finally, you need to know the meaning of the sigma symbol. Okay, let's start with some pretty simple questions. Ones I'm sure you'll have absolutely no trouble in solving, really just using them to introduce the notation. So we call the first term in the sequence u1, second term is u2, third term is u3, and the fourth term is u4. And in this sequence, hopefully you can spot that we've got to subtract 3 every time. So u5 is just going to be 5 take away 3, which is 2. u6 will be 2 take away 3, which is -1, and u7 is -4, -4. Okay, and then just writing down the rule, we need to subtract 3 from the previous term. Let's move on. So this next sequence isn't actually an arithmetic sequence. If you notice, from term 1 to term 2, we could add 1, but then that wouldn't work from term 2 to term 3. So yeah, you spotted it's a doubling sequence instead. It's a geometric sequence. So instead of a common difference, we have a common ratio. So we can figure out pretty quickly then that u5 would be 16, and u6 would be 32, and u7 would be 64. And we can just make a quick note of we need to multiply the previous term by 2. There is a better system for expressing these term-to-term rules. It's called a recurrence relationship, and we'll look at that in a few minutes. Okay, and the final example. So in this case, it's not an arithmetic sequence, because if we added 2 to get from 1 to 3, it wouldn't work. It wouldn't take us from 3 to 7. And it's not a geometric sequence in the same sense that we can't just double 1 to get 2 and then or times by 3, it just wouldn't work. So actually the term-to-term rule here is that you've got to double the previous number and then add 1. So in this case, u5 is going to be double 17, which is 34, add 1 is 35. u6, we're going to double 35 and add 1, so that's 71. And then u7 is going to be 143. So we're going to say multiply by 2, then add 1. Okay, let's move on. Example 2. Find the nth term of a sequence which is given by un equals 3n minus 1. Find the first term, third term, and the 19th term. Okay, so we've got that un equals 3n minus 1. If we want to find the first term, that's u1, all we've got to do is sub in that n is 1. So that's 3 times 1, and then subtract 1, giving us an answer of 2. If we start with that formula again, the third term then, u3, is going to be 3 times 3, take 1, so u3 is 90 over 1's 8, and then u19, we'll do that next, so u19 is 3 lots of 19 minus 1, so that's going to be 57, take away 1, 56. Okay, so we're just getting used to using the terminology. The math is just the same as the maths that you studied at GCSE. We're just introducing a new way of describing what's going on. Okay, let's move on. So similar here, but just the formula is a bit more complicated. we want to find the first three terms of this sequence, which is defined by un equals n squared over n plus 1, and then the 49th term. So u1 will be given by 1 squared over 1 plus 1. So that's just going to be 1 squared is 1 over 2, so half. u2 will be 2 squared over 2 plus 1, which is going to be 4/3. And then finally u3 is 3 squared over 3 plus 1, so that's 9/4. And then the 49th term, it's just the same process again. So u49 will be 49 squared over 49 plus 1, which I need to calculate for that, but 2401 is 49 squared all over 50. And there we go. Okay, example 4. Find the value of n for which un has the given value. So in this case, we've got un is 5n minus 2, and we're looking for a value of 153. So it's a bit like saying which number in the sequence will have the value 153. All we need to do here is to solve that 153 is equal to 5n minus 2. So add 2 to both sides, so it's 155 is 5n, so n must be 31. Let's try b then. It's a little bit more complicated. So in this case we've got that 72 is the value we're looking for, and the nth term is n squared minus 7n plus 12. So really this has just now become a quadratic problem to solve. If we take 72 from both sides, then we've got n squared minus 7n minus 60. Okay, I'm sure you know how to solve a quadratic. If not, it's an essential skill really for this year, so you need to get up to speed pretty quickly. We're looking for numbers that multiply to make negative 60 and add to make negative 7. And negative 12 and positive 5 will do the job there. Okay, so we've got that n equals 12 or n equals negative 5. Thinking about it for a second, it doesn't really make sense for us to have a negative place in the sequence. Remember, we're talking about places in the sequence where the first place is where n is 1, the 12th place is where n equals 12. So a place in the sequence of negative 5 doesn't make sense. We discount the negative value there. So the only value that we can have is n is 12. Okay, example 5. A sequence is generated using the formula un equals an plus b, where a and b are constants. Given that u3 is 5 and u8 is 20, find the values of a and b. Well, this brings in another essential skill for AS level, which is to be able to solve simultaneous equations. We're going to use the facts we're given to set up 2 simultaneous equations and then solve them to find a and b. Okay, so we know that when u3 is 5, so basically we know that 5 equals 3a plus b. The third term is equal to 5. So there's one equation. And then if we use that u8 is 20, that means when n is 8, un is 20. So we've got this, 20 equals 8a plus b. Okay, and again, a set of simultaneous equations that we can solve. So just subtracting, if we do 2 take away 1, then we've got 15 equals 5a b's cancel. So a must be 3. Then we can sub that into one of the formulas, doesn't matter which one. So sub into equation 1, and we get 5 equals 9 plus b. So b must be -4. Okay, so just to finish that off, a equals 3, b equals -4. Just summarise your answers. Makes it easier for the person who's checking your work. Okay, so recurrence relationships. Well, in the first example, we looked at these numbers 1, 3, 7, 11, and we talked about the connection being that you have to double the previous number and add 1. So we can use recurrence relationships to explain what's going on here. And we use this formula. So we say that un plus 1, so basically this is telling us how to find the next term in the sequence is the previous term, un. Then in this sequence we'll have to times it by 2, so we can stick a 2 on the front and add 1. Let's just see if that works. So if I want to find the fifth number in the sequence, well, the fourth term, u4, is 11. So u5, to get the next term, I've got to do 2 times the previous term and then add 1. So u5 would be 22, add 1, which is 23. That makes sense. Let's see if we can use these and put them into practice. Find the first 4 terms of the following sequences. So let's look at A first of all. And the relationship is that the next term is given by the previous term, add 4. So we always need a starting point. So if u1 is 7, then u2 is just that term, add 4, which will be 11. u3 will be 11, add 4, which is 15. And u4 will be 15, add 4, which is 19. It's that simple. Okay. Sometimes we have a sequence, like in example B, where it doesn't just work off the previous number, but it works off the one before that. So that's what we've got in this situation here. We've got that un plus 2 is 3 lots of un plus 1 minus un. Let's see if we can use that. So u1 is 4, and u2 is 2. Let's see if we can find u3. Okay, so u3 will be 3 lots of u2 minus 1 lot of u1 using the recurrence formula there. So that will be 3 lots of 2 minus 4. So 6 minus 4 gives us an answer of 2. Let's see if we can find u4 as well. Here we go. So that'll be 3 lots of u3 minus a u2. So that will be 3 lots of 2 minus 2. So 6 minus 2, which is 4. Okay, example 7. A sequence of terms, un, where n is greater than or equal to 1, is defined by un plus 2 equals m un plus 1 plus un, and it gives you the first 2 terms. It gives you that u1 is 2 and u2 is 5, where m is a constant. So that's not going to change throughout the question. Find an expression for u3 in terms of m. Okay, so u3 will be m lots of u2 plus 1 lot of u1. I'm taking that from here, from this equation here, this recurrence relationship. Again, I'm just subbing in that. Oops, Something in that. If that's U3, that must be U2, that must be U1. So we've got values for U2 and U1, we can just put those straight in. So U3 will be m lots of 5, so we call that 5m, plus U2, which is 2. And there we go. So U3 is 5m plus 2. Okay, let's move on and look at U4 now. So U4 will be given by m lots of U3 plus the U2. So that will be m times by all of this, 5m plus 2. Because that was our value for U3. And plus U2, which is 5. And if we tidy that up, it will be 5m squared plus 2m plus 5. Okay, so for part C then, it says given that U4 is 21, find the possible values of m. So I think it looks like we're going to be solving a quadratic here, doesn't it? We've got 21 equals 5m squared plus 2m plus 5. So let's take 21 off both sides. 5m squared plus 2m. What's that going to be? Minus 16? Minus 16. Okay, so now we're going to factorise that. Again, it's an essential skill for AS level that you can factorise a quadratic, including quadratics with a number in front of the squared coefficient. So there's only one way you can make 5m squared, and it's 5m times m. We're lucky there, we've got a prime number. We've got a few options for this 16, so we need to just think through a few of those different options, try them out, and see if you can factorise that quadratic. I haven't tried a few different options out. This is the one I think that works. 5m minus 8 and m plus 2. Just check that. So if I multiply this quadratic out, just check that you get 5m squared plus 2m minus 16. 5m times 5m is 5m squared. We're going to get a minus 8m and a plus 10m, so that'll give us the 2m middle term, and then negative 8, negative 8 multiplied by positive 2 will give you negative 16, so that looks good to me. And that's telling us then that m must either be carry the 8 over, divide by 5, 1.6, or m equals negative 2. Okay, let's go back to this question. M's not a place in the sequence, so there's no problem with it being possibly a negative number, or even a decimal, or a fraction. So that's absolutely fine. Okay, that's the end of this video.